Okay, now let's move to the second question. What percent is this of the number of oxygen molecules you could get from a breath at sea level? Okay, so they ask us to determine the number of oxygen molecule at the sea level as well, right? And then compare it with this one at the top to see what is the percent, right? Okay, so why they have to be different from each other at the sea level and at the top of the mountain? Because of the pressure change, right? So I guess here that we assume that the volume of the ocean is still the same to be 21% of that average breath, right? So here, what we need to find is actually the percentage between the top and the sea. And I will just arrange them a little bit like this. We can see that the number of molecules related to the number of mole by this equation, right? So then we can see that the numerator and the denominator will have the same NA, the arbitrary number. So it can be cancelled out. So now this ratio is just this ratio. And then from the equation state of the ideal gas, then we can see that the number of mole will be calculated as the PV over the RT. So then this I just arrange them like this. And then here we just have RT is at the same, right? Because that will be that at the same temperature. Minus 15 Fahrenheit. So that's the same T and R just a constant, so the same. So I can just cancel them again. Now what left is just this terms and this term. And we know that the volume here is just like the same volume, right? The same volume of the oxygens, that 21% of the breath to be the volume of the oxygens. Okay? So by doing this, we can see that basically the fraction that we need to find, the percent that we need to find, is just actually the ratio between the pressure at the top over the pressure at the sea. And at the sea level, just imagine that this is the definition. Imagine that just a columns of air that on a unit of area, that should be 1 atmosphere, so that should be 1/3, and that's why we got it to be like 33%. So if you can see this ratio right away, the math can be simpler, right? But if you don't, then what you need to do is just calculate the number of oxygens at the sea level by plug in the values at the sea level. So you have to change the pressure to be the pressure of 1 atmosphere, and also the volume is still the same. So then you will just do everything here and then find the number of oxygens at the sea level as well, and then got the new one over this one to get the same percent. But if you notice this relationship right away, then it can save you some time. Okay, so I hope that it makes sense to you for this question. If you still have some questions, please let me know and feel free to leave a comment below. Thank you. Good luck.